Welcome everyone, Math 100. We are working on section 1.5 today, the dreaded long division. Let's start with some properties of division involving 1 and 0. So these will come up every so often. Any number divided by itself gives us a 1. If you think of this in terms of objects and breaking it up into piles, we have 8 objects. If we take 8 objects, how many piles of 8 can we make? We can make one of them. Well, here we're doing 12 divided by 1. Any number divided by 1 is itself because we're taking 12 objects and we're breaking them up into piles of 1. So how many piles of 1 can we make out of 12 objects? We can make 12 of them. And we can think through all these this way. Here we have 0 objects. 0 divided by anything is going to be 0. So we have 0 objects. We're going to put them into piles of 15. How many piles of 15 can we make out of 0 objects? Well, we can make 0 piles. Now this one, a little bit different. We have 9 objects and we want to put them into piles of 0. Well, how many piles of 0 can we make? As many as we want. So that one doesn't really have an answer. It doesn't really even make sense. So that's why we call this one undefined. So that's how you can determine between these two, which are very commonly confused with each other. I see a lot of people writing either 0 or undefined, mixing them up. So these, just think of them in terms of number of objects. We're breaking them up into certain piles. If it makes sense, it's 0. If the argument just makes no sense at all, that's going to be undefined. All right, now we're going to do long division. So problems are often presented like this. And we're going to need to put these into long division form. So 187, this is the number being divided into, so that goes underneath the division symbol. And the number we were dividing, 11, that goes on the outside. We're kind of switching spots there. And once we have it all set up, now there's a procedure we're going to go through. And it's going to involve asking some questions. And the first question is, how many times does 11 go into the first number here? 1. Well, 11 doesn't go into 1 at all. Now, when you first start these out, it's really a good idea to, if it doesn't go in, just put a 0 up here. It's a placeholder. And it helps keep things straight. Keeps things straight as to what number we're on here. All right, so we've done the 1. Term of 11 goes into 1 0 times. Now we're going to do bring down the next digit, 18. We're going to consider this entire number 18. So how many times does 11 go into 18? Well, that's 1 time. 11 times 1 is 1. And now we take the number up here and multiply it by this 11 and bring it down here. So 1 times 11 is 11. And then subtract. So we're going to do 18 minus 11 is 7. And that's 1 cycle through the process. All right? So just to repeat, we're looking at how many times does the number go into this number down here. Remember, when we multiply, we want a number here that is less than this one. If you get a number here that's bigger than this one, it means we need to reduce this number up here. All right, this one works, so 1 times 11, multiply to get this one, and then subtract. So that's 1 cycle. Now we're going to start the next cycle by bringing down the next number. If you have any numbers left, bring them down 1 at a time. So now we have a 77. Now we have to figure out how many times does 11 go into 77? Well, that is 7 times. So the 7 goes up here. Now 7 times 11 gives us 77, and then subtract. Now we're down to a 0, so that means we're done. And here's our answer. 187 divided by 11 is 17. It can be a lot of steps to this process. It can become very confusing. So what we're going to do is we're going to work through starting with 1 or 2 step problems and then work our way up to the bigger problems. So we're going to start off with 28 divided by 2. So 28 is the number being divided into. That goes underneath the division symbol, and 2 goes on the outside. So first thing we want to do is figure out just look at the first digit inside here. See, how many times does 2 go into 2? Well, that's 1 time. So 1 goes up here. Now we multiply. 1 times 2 gives us the 2 here. and then subtract. 2 minus 2, only subtracting where we had digits here. So 2 minus 2 gives us 0. And then, starting the next cycle, we're going to bring down the 8. And the 8 goes here. Now we need to know how many times does 2 go into 8. And that is going to be 4 times. So we got an 8 here. Subtract to get 0. Get down to the 0 and we're done. So 2 divided by 28 is 14. So this one you might be able to do it in your head, but just go through the procedures so we can work on that procedure. 93 divided by 3. And just a reminder, if you're viewing the videos, make sure you pause when you get to the your turns, work through the your turn, and then restart the video. Because I'm not going to stop. 93 divided by 3. All right, I'm going to look at the first digit now. How many times does 3 go into 9? That is 3 times. So 3 times 3 gives us a 9 down here. And now we subtract. 9 divided by 9 is 0. And now we can bring down the 3. And start the next cycle. How many times does 3 go into 3? That is 1 time. 1 times 3 is 3. Subtract to get 0. And we have an answer of 31. Well, the first example, everything divided evenly, digit by digit. Of course, that always won't be the case. Now, next up, we're going to divide 3 into 78. So we need to figure out how many times does 3 go into 7 without going over. It's kind of like blackjack. You don't want to go over the number. So we can do 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. 9 goes over, so we're going to do the 6. So we're going to multiply by 2. 2 times 3 gives us 6. And that's the largest number, less than or equal to 7. Now we subtract. 7 minus 6 is 1. And that's the end of the first cycle. All right, now we're going to bring down the 8. And now we see how many times does 3 go into 18? Well, that is going to be 6. 6 times 3 is 18, so it goes in evenly. We get a 0, so we're done. So our answer here is 26. Your turn, number 2. 68 divided by 4. First digit, 6. So 4 is going to go into 6 one time. Now 1 times 4 gives us 4, so 4 goes down below the 6. And subtract, 6 minus 4 is 2. All right, that's the end of cycle number 1. I'll bring down the next number, 8. Now we're going to figure out how many times does 4 go into 28. And that is 7. 7 times 4, that is 28. Remember, you're only going to multiply by the last digit here. We're not multiplying by 17, just multiplying by 7. 7 times 4 gives us 28, subtract to get 0, so we're done. And the answer is 17. Add on a digit on this one. Now we're going to do 940 divided by 4. So looking at the first digit, got a 9. 4 goes into 9 2 times. 2 times 4 is 8. All right, now we can subtract. 9 minus 8 is 1. And now we'll bring down the 4. So 4 comes down. Now we're going to figure out how many times 4 goes into 14. It says 3 times. And 3 times 4 gives us 12. And now subtract to get 2. And finally, we're going to bring down the 0 here. Now we got to figure out how many times is 4 going to 20. That is 5. 5 times 4 is 20. So we got 20 here, subtract. We're out of room here, but we subtract to get 0. So our answer then is 235. And that brings us to your turn, number 3. $7.95 divided by 5. So 5 goes into 7 one time. 1 times 5 is 5, and we'll subtract to get 2. All right, now bring down the next digit, it's 9. 5 goes into 29 5 times. So got 5 up here, 5 times 5 is 25. So 25 goes down here, and subtract to get 4. And we'll bring down the last digit, which is a 5. And now 5 goes into 45 9 times. 9 times 5 is 45. Subtract to get 0. And our answer is 159. Now it's a good idea to start getting to larger numbers like this to check. So since we've divided to get 159, we're going to do the opposite. And multiply. So do 159 times 5. Right? 9 times 5 is 45. Carry the 4. 5 times 5 is 25, plus 4 is 29. Carry the 2. 1 times 5 is 5, plus 2 is 7. 795, and we're right back where we started from. All right, so make sure you're checking these. It's a great way to catch mistakes. All right, next up, 5 into 465. Now this one's a little different in that we cannot divide evenly into 4. So we're going to skip over that one. And since 5 goes into 4 0 times, I'm going to put my placeholder up here, 0. All right, now, this is just like when we bring down the next number. Well, the next number is already there. So now we're going to do 46. How many times is 5 going to 46? That is 9 times. And then 9 times 5 is 45. So we'll subtract 45 to get 1. Now we'll bring down the 5. And 5 goes into 15 3 times. 3 times 5 is 15, subtract, get 0, so our answer is 93. Your turn, number 4. 492 divided by 6. Now 6 doesn't go into 4. Put the 0 placeholder above the 4. Now we're going to do 49. So 6 goes into 49 8 times. 6 times 8 is 48. Another example of knowing those times tables is really helpful. Subtract to get 1 and bring down the 2. 6 goes into 12 2 times. 2 times 6 is 12. Subtracting is 0, so we're done. And the answer is 82. All right, I'm going to start dividing by some 2-digit numbers. We got 3010 divided by 14. Now clearly, if a 2-digit number is never going to go into a 1-digit number, so traditionally we just start with the first 2 digits in both cases. So how many times does 14 go into 30? That's going to be 2 times. 2 times 14 is 28. And then subtract to get 2. There's the end of the first cycle, and we'll bring down the 1. Now 14 goes into 21 one time. So 1 times 14 is 14, and subtract to get 7. Bring down the 0, and we do 70. How many times does 14 go into 70? That'll be 5 times. 5 times 14 is 70, subtract to get 0. So our answer is 215. Your turn, number 5. Do an 1872 divided by 12. All right, we're going to skip over that first digit, go right to the second digit, 18. How many times does 12 go into 18? 1 time. 18 divided, or minus 12 is 6. Now we'll bring down the 7. And how many times does 12 go into 67? That'll be 5 times. 5 times 12 is 60. Subtract to get 7. Now we'll bring down the 2. Now how many times does 12 go into 72? That'll be 6 times. 6 times 12 gives us 72, subtract to get 0. So our answer is 156. Now, all the exercises we've seen so far, we've had evenly dividing numbers. So 12 divides evenly into 1872, 14 divides evenly into 3010, but that often doesn't happen. In fact, it usually doesn't happen. It's pretty rare that something would divide evenly like that. So let's look at an example of division with a remainder. So we're going to divide 32 into 1036. So let's start by looking at the first 2 digits. We've got a 10. 32 divides into 10 0 times. So I'm going to put a 0 over the rightmost digit as a placeholder. Just to remind me that I've already tried 10. All right, now I'm going to move on to 103. How many times does 32 go into 103? That'll be 3 times. Now we'll do 3 times 32, and that is 96. So now we're going to subtract 96 from 103. That gives us 7. And then bring down the next digit, the 6. Now how many times does 32 go into 76? That'll be 2 times. 2 times 32 is 64. And then subtract. Now this is different from the other ones, that we didn't get a 0 here. Now we have to examine this number. 12 is less than 32, so 32 can't go into 12, so we didn't just make a mistake up here. All right, so if we get to a point where we have a number left over that's less than the divisor, what we're dividing by here, and we have no more digits to bring down, that means we're done and we have a remainder. All right, so the answer, just like over here, we got an answer 156. Well, the answer here is 32. So just a coincidence there, we got the same number. So we're going to write 32. and then R for remainder, followed by 12. So the answer is 32 R 12. 32 with 12 left over. All right, that begs the question, how in the world do we check something with a remainder? Well, what we're going to do is we are going to take our divisor, multiply by the answer without the remainder first. So we're going to do 32 times 32. All right, so that gives us 64 on the first line, 0 there, 96, add them together, and we get 1024, 1024. Okay, so notice that this number does not match what we started with, but we haven't included the remainder yet. We still have this remainder. So we're not going to multiply that, we're going to add it on. Add on that remainder, and we get 1036. And that matches what we divide by. So, to check, take your answer, multiply it by the divisor, and then add the remainder, and we should get right back where we started. All right, now just like before, I'm going to start with some straightforward ones, some shorter problems. 1058 divided by 6. Let's see, 6 doesn't go in for 1, into 1, so we'll put a 0 there. Now, how many times 6 go into 10? That is 1 time. 1 times 6 is 6, subtract to get 4. Bring down the next one. 6 goes into 45 7 times. 7 times 6 is 42. Subtract to get 3. Bring down the 8. 6 goes into 38 6 times. 6 times 6 is 36. Subtract to get 2. So our answer is 176. 2 is the remainder. And make sure you check. Your turn, number 6. $24.63 divided by 5. All right, 5 goes into 2 0 times. I'll put a placeholder there. 5 goes into 24 4 times. 4 times 5 is 20. And subtract to get 4. Bring down the next number, 6. 5 goes into 46 9 times. 9 times 5 is 45. Subtract to get 1 and bring down the 3. 5 goes into 3 2 times, or 13 2 times. 2 times 5 is 10, subtract to get 3. 3 is less than 5, so we are done. Answer 492, remainder 3. All right, let's look at some 2-digit problems now. Next example, 2587 divided by 23. So 23, look at the first 2 digits, 25, it'll go in 1 time. 1 times 23 is 23, subtract to get 2. Now we'll bring down the 8. 23 goes into 28 1 time. Subtract to get 5. Now we'll bring down the 7, I got 57. So 23 is going to go into 57 2 times. So you got 2 here, 2 times 23 is 46. Subtract to get 11. 11 is less than 23, so we are done. So no more numbers to bring down. So our answer, 112, Remainder 11. Your turn, number 7. $21.46 divided by 18. $18 goes into 21 one time. Subtract, get 3. I'll bring down the 4. Looks like 18 times 2 is 36, so that's going to bring us over. So just another 1 there. 1 times 18 is 18, and we'll subtract to get 16. And then bring down the 6. Now 18, now we'll do a little estimating here. See, 18, let's round that to 20, and 20 times 8 would get us to 160. So let's try 9. Let's see what 9 brings us. Okay, 9 times 8, that's 72. Carry the 7. 9 times 1 is 9, plus 7 is 16. So 162. So that way of estimating, that's very helpful in approximating what number you're going to need up here. And we'll subtract, get 4. So that gives us an answer of 119. Remainder 4. All right, bigger number here. We got 88 going into 54880, 54,880. All right, so let's try that estimating thing again to see what we can do here. 88, let's round that to 90, and 9 times 6 is 54. So that gets us pretty close. So let's try a 6. All right, 88 doesn't go into 5 or 54. 0 there, we're going all the way into 548, and we're going to try a 6. All right, 6 times 8 is 48. Carry the 4. 6 times 8 is 48, plus 4 is 52. So a 528. All right, now subtract. Get a 0 here, a 2 here, so 20 is left, and then bring down the 8. So now we're going into 208. If this were a 90, I could multiply by 2 to get 180. That's pretty close. Let's try 2. 2 times 8, that is 16. Carry the 1. 16 again, plus 1 is 17. So 208 minus 176. So that'll give us a 2 here. 32 difference there. Now I got one more digit here, so we're going to bring that down. And let's see, 9 times 3 is 27. So I'm going to guess that 3 will get us close to 320. All right, 3 times 8, that is 24. Carry the 2. 3 times 8 is 24, plus 2 is 26. All right, remainder is 56. That is less than 88, and we have no more numbers to bring out, so we're done. So the answer is 623. Remainder 56. All right, so this gets a little tricky at this stage. We're multiplying by larger numbers like this. Lots of carrying, stuff like that. So just take it one step at a time. Be careful. And might want to check as you go with a longer problem like this. And it's okay to check with a calculator. Just keep in mind you don't going to be able to use it on the exam. All right, your turn, number 8. 42 into 32,909. All right, 42 doesn't go into 3 or 32. So we'll put a 0 placeholder there, and we're going to go into 329. So what if we did, see, 4 4 times 7, no, 4 times 8, 8, 16, 32. All right, so we did 4 times 8, that would give us 320. But that extra 2 is going to bring us over. So I don't think we can do 8. Let's try 7 and see if that works. All right, 7 times 2 is 14. Carry the 1. 4 times 7 is 28, plus 1 is 29. So we get 294. Now subtracting, a 5 here, 32 minus 29 is 3. So 35. So it looks like that worked. Because we got a number that's less than 42, so that's good. All right, bring down the 0. Now we're going to the 350. Let's see, so 4 times, I think 8's going to do it this time. If we add another 42 onto this, should get us right under 350. So let's do 8. 8 times 2 is 16, carry the 1. 4 times 8 is 32, plus 1 is 33. So 336 there. Subtract to get 14. All right, that's less than 42, so that's good. And we'll bring down the 9. Now we're bringing 42 into 149. Now 4 times 4 is 16. So 40 times 4 is going to give us over 149. So let's do 1 less than that, or 3. 3 times 2 is 6. 3 times 4 is 12. So 126. Subtract to get 3, and 2 there. So 23, and so we get an answer of 42. Remainder 23. What am I doing? Look at that. So that's 483 or 783. There we go. That's makes a little bit more sense there. 783 remainder 23. Okay, now to check, I'm going to do 783 times 42. All right, 3 times 2 is 6. 8 times 2 is 16. Carry the 1. 7 times 2 is 14 plus 1 is 15. Next row, put down a 0. 3 times 4 is 12. Carry the 1. 8 times 3, 2, 33. Carry the 3. And 7 times 4 is 28 plus 3 is 31. And that gives us 3, 2, 6, 6. We got 8, we got 8. Okay, so that's 32886, and we're going to add on the remainder. And we get a 9, a 10, carry the 1, 9, 3, 2, 909, which is what we're dividing into. So make sure you do a quick check like that. Catch lots of mistakes that way. And that is it for section 1.5. This is a procedure, it just takes a lot of practice. So just do as many as you need until you've got it down. All right, have a great day.